Okay, so let's take a look at page 2 of that review. Here we go. Get that visualizer going. So let's see. For this particular problem, we said we've got this function right here. We've got our rational equation. And we want to know where it is not continuous. So now discontinuities can happen in a variety of places. One is piecewise, we already looked at that. But it also happens when you have both removable and non-removable discontinuities. So if we were to take a moment to factor this problem, what we would see is clearly there are no common factors top and bottom that would actually generate any kind of a hole in this graph. These are both vertical asymptotes. And so at x equals 7 and at x equals -3, we have two non-removable discontinuities. These are both non-removable. And in fact, if we wanted to, non-removable could be a jump or an asymptote. These are more specifically infinite discontinuities. If you graph them, you'd have these infinitely large breaks. Okay, moving on a little bit further. Couple of quick little problems on limits in number 5. Remember, if somebody asks you to take a limit, the first thing you do is you say, forget it, I'm just going to plug it in and see what happens. So if we substitute the number -2 in and just see what happens, what I got is -15 on top, and I've got -4 on the bottom, and I guess we're good. 15 quarters, we're done. Sometimes they're really easy problems, and those do exist on the test that's coming up your way. Sometimes they're not, because in this particular case, when we try to plug it in, I plugged it in and I got 0/0. Now, the beautiful thing about calc is every single time you got 0/0, that means by the fundamental theorem of algebra, if you plug in 0 and if you plug in a number and you get 0, then you have a root. That means it has to be a factor. That means if x plus 5 works here, it's going to work there too, which means if I go to factor that, it's going to have to be an x plus 5 times something else. And it would have to be a 2x, and it would have to be a -3 to make that work. Now, we should check it to make sure we haven't done something stupid, but the reality is this has to be the answer. I've got 2x squared, 10x minus 3x is 7. And so you'll notice as we get infinitely close to -5, we can now plug that in. And the limit as I approach -5 gets close to -10 minus 3, or in fact, -13. Now, our last one of these is again going right back to that squeeze theorem. Remember, we want to do the limit as h goes to 0 of the sine of h over h, highlighting yet again that I want those h values to match. I want the argument in that sign to match that value in the denominator. And so since this says 4 theta, I want this down here to also say 4 theta. So if we take the limit as theta goes to 0 of the sine of 4 theta over 7 theta, notice what we can do is it still is the same problem that I had, but I really need a 4 to go alongside with that, and therefore I'm going to put a 4 in the numerator. Remember, we know that this limit is 1, therefore I get 4/7 times 1, which of course is 4/7. Now, for the last question on this particular page, which will be the ending of this video, we have all sorts of interesting little pieces that are going on in here. And so what I decided was to, rather than make one from scratch, I had decided I would actually display something that I've already made. So right here, I have a graph that I've already generated. And that's sitting right here that you can see. So the first thing I notice is right here, hopefully you can see that I'm highlighting this portion, that the limit as x goes to infinity has to go to -1. So here on the right side, you're getting close to -1. Now, of course, it could have come to -1 from on high, from above it, or from below it. It doesn't matter. We have a limit as you go to -infinity of the number 2. So we have a secondary horizontal asymptote. And we could do what I did on the other side and have it dip down underneath and come back up. But what I did is I highlighted each of those pieces, one little chunk at a time, so that you could see how every single facet is actually satisfied. Notice in yellow, as I try to approach the number 1 right here, from the left side, it goes down to -infinity. In green, as I approach 1 from the right side, it goes to +infinity. Pulled out a lot of colors on this one to make sure that you could see that I've satisfied every single piece of this story. So hopefully you can see how all of that pans out. But keep in mind, there's an infinite number of answers that would be valid. They just have to have those little tags of blue, pink, green, blue, yellow, etc. But lots of extra little things could happen in the middle that I was not real clear about. I didn't say anything about increasing, decreasing, or anything like that. So you can get a lot of different answers that would actually satisfy those. So, okay, hopefully that works for page 2. See you back in class.